So welcome guys, welcome to Learn Economics with Abayomi, and on today's video we'll be looking at how to solve the Cournot oligopoly problem. And we have this question here. We say, suppose there are two firms producing homogeneous products. The inverse demand function for the product of the firm is given by P equal to 200 minus 2 open brackets Q1 plus Q2, where P is the price of the product and Q is the quantity of the products produced by firm. The cost functions of the firm 1 and firm 2 are given respectively. So we have the cost function for firm 1, which is C open brackets Q1 equal to 120 Q1 minus 3 over 2 Q1 raised to power 2. And we have the cost function for firm 2. Now, the first thing we have to do is to obtain the reaction function for the firm. So, for us to obtain the reaction function of the firm, we can say, since we have our price, we have our price, so we can easily say 200 minus, we multiply these two by everything in the bracket to open the bracket, so we can say 2Q1. That will change to minus, since we are opening the brackets. That will be 2Q2. Now we have our total revenue for firm 1, which is P times Q1. So we can easily slot in this P inside this place. So we say 200 minus 2Q1 minus 2Q2 Q1, right? So we multiply this by everything in the bracket, so we can say CR1 equal to 200 Q1 minus 2 Q1 square minus 2 Q1 Q2. So we have the total revenue. So we can find the marginal revenue. A marginal revenue for Q1 will be the derivative of PR1 over the derivative of Q1, and that will be 200 minus 4Q1 minus 2Q2. So we have the marginal revenue. So for our equilibrium condition, we know that our MR equals MC. Our RM equals MC1. So now this is our cost function for Q1. So we can bring this one here. Since this is our total costs, the total cost is 120 Q1 minus 1.5 Q1 square. So we can find the marginal costs. So when we find the marginal costs, so we can have the marginal costs will be 120 minus 3Q1. So that's the marginal cost. So we equate our MR and our MC. So when we equate them, we have 200 minus 4Q1 minus 2Q2 equal to 120 minus 3Q1. Then we collect like terms. When we collect like terms, we can have 200 minus 120, right? Then we have minus 2q2 equal to minus 3q1 plus 4q1. So we can say 200 minus 120, that is 80 minus 2q2 equal to minus 3q1 plus 4q1. That will be q1. So this is our reaction function for Fem 1. The reaction function for Fem 1. So now we can find the reaction function for Fem 2. To find our reaction function for Fem 2, we can also do the same. We have the total revenue for Fem 2 will be P times Q2. So we can easily slot in our P. We can easily slot in our P like we did for Fem 1. We can easily slot in our P and we say TR2 equal to 200 minus 2Q1 minus 2Q2 close bracket Q2. So we can say TR2 equal to 200 Q2 minus 2 Q1 Q2 minus 2 Q2 square. I hope you get that. So we find the imaginary revenue for Fem 2 of the partial derivative of total revenue of Q2, the partial derivative of the total revenue of Fem 2 over the partial derivative of Q2. So we can say we have 200 minus 2Q1 minus 4Q2. So we have that. So we have, and we, of course, we know that our equilibrium condition for profits maximizing oligopoly markets is the marginal revenue of Fem 2 will be equal to marginal cost of Fem 2. So our cost function for Fem 2 is this, which is 100 Q2 minus 3 over 2 Q1 square. So we can easily put, these are total costs for Fem 2. Our total cost for Fem 2, 1.5 Q2. Then we can find the marginal cost. When we find the marginal cost, we can say 100 minus 3Q2. Then when we equate the marginal cost and marginal revenue, when we equate them, so we can have 200 minus 2Q1 minus 4Q2 equal to 100 minus 3Q2. So we collect like terms. So we can have 200 minus 100 minus 2Q1 equal to minus 3Q2 plus 4Q2. This will become 100 minus 2Q1 equal to Q2. This is the reaction function for Fem 2. For Fem 2. So we successfully found the reaction function for the two Fems. So our next task is to state the Cournot condition and obtain the equilibrium for the above market. The Cournot condition is our best reaction function for firm 1 will be equal to the best reaction function for firm 2. That's the Cournot condition. Is 80 minus 2Q2 equal to Q1. And the best reaction function for firm 2 is 100 minus 2Q1 equal to Q2. So we equate them, so we can easily slot it in. So we can say that, our Q1 equal to 80 minus 2Q2. So we can slot in this for Q2. So we can say Q1 equal to 80 minus 200 minus 2Q1. So we can easily solve Q1 equal to 80 minus 2 times 100, that's 200 plus 4Q1. So we say Q1 equal to 80 minus 200, that's minus 120 plus 4Q1. So we can easily say 1 minus 120 equal to 4Q1 minus Q1, and that's minus 120 equal to 3Q1. No, when this one comes to the other side, when this one comes to this, it becomes plus. So that will be Q1 equal to 120 over 3, and that's Q1 equal to 40. So we found the equilibrium for Q1. So let's solve for Q2 now. So to solve for Q2, we can easily slot in this Q1 in this. So we have Q2 equal to 100 minus 2Q1, and that's Q2 equal to 100 minus 2 open bracket 40. Q1 is 40. Q2 equal to 100 minus 80, and that's Q2 equal to 200. So our Q1 is 40, our Q2 is 200. So we successfully found the reaction function and the equilibrium of condition for the Cournot. So thank you so much for watching this video, and I hope you enjoyed it. Please like the video and also please subscribe to the channel. So thank you and see you next time.